Let us take this previous JEE Advanced question now. If R maps to R is a differentiable function such that f dash x is greater than 2fx for all x belongs to R and f0 is equal to 1, this information is given to us, then we need to check for the monotonicity of the function. Fx is increasing in 0 to infinity, fx is decreasing in 0 to infinity, and we have the informations. So within 0 to infinity, we need to check the options. Now this is a differential inequation. See, f dash x minus 2fx is greater than 0. We can write the equation like this. Now here, what is the integrating factor? Of course, integrating factor will be e to the power minus 2x. We know that for an expression f dash x plus gx into fx, for this type of expression, integrating factor is e to the power integral gx dx. This is the integrating factor. So using that same idea here gx is nothing but minus 2. So integrating factor will be e to the power minus 2x. So by that, if you multiply both the side, multiplying both the side with e to the power minus 2x, which is a positive quantity, if I multiply both sides by e to the power minus 2x, then you see that the left hand side will become the derivative of e to the power minus 2x into fx. Derivative is greater than 0. What does it mean? That means that this function e to the power minus 2x into fx is a strictly increasing function. This is a strictly increasing function because the derivative is always greater than 0 for all x belongs to R. This is true for all x belongs to R. That means this function is a strictly increasing function. If this function is strictly increasing function, then let us come in the domain of 0 to infinity. If I consider x is greater than 0, then we can say e to the power minus 2x fx should be greater than e to the power minus 2 into 0 into f0, because e to the power minus 2x into fx is an increasing function. So if x is greater than 0, then this should be greater than this. What is the value of this? This is e to the power 0, 1 into f0. f0 is also 1. So from here we can say e to the power minus 2x into fx is greater than 1. Now transferring this factor on this side, we can say fx is greater than e to the power 2x for all x belongs to 0 to infinity. This statement is true. Fx is greater than e to the power 2x for all x belongs to 0 to infinity. So this option is, we have got option C, that is correct. Option C is correct. That one we can definitely say. And since fx is greater than e to the power 2x, now from here what we can say? From here we can say f dash x is greater than 2fx and fx is greater than e to the power 2x. That means this value is more than 2 e to the power 2x, right? F dash x is greater than 2fx, fx is greater than e to the power 2x. So this is greater than 2 e to the power 2x, which is actually more than 0. That means f dash x is greater than 0. F dash x is greater than 0 for all x belongs to 0 to infinity. What does it mean? Derivative is greater than 0 means what? Fx is increasing function in 0 to infinity. And fx is increasing, so this option is wrong. And f dash x is, we have proved that f dash x is greater than 2 e to the power 2x. That means f dash x is less than e to the power 2x is wrong. So correct option is A and C.